Today we're going to do a real short video. I owe you guys something, it's been a little while. We're going to go over some theoretical or like experimental probability, simple probability basically, and then number of total outcomes if we have like compound events, so more than one thing happening at a time. The first one here, theoretical or experimental probability. If we were given a chart, and I believe this was for t-shirt sales, different colors, something like that, say you have a fundraiser, which one's your most popular, in this case it's yellow, we would want to think, maybe use this to predict in the future how many of a certain color to buy or something like that. The specific example we have is using this table, using the information that we have. What's the experimental probability that pink would be the next shirt that was bought? So we need to think about using what we already know. We have 2 have been bought so far out of a total. So when we're saying like out of a total, something like that, we need to think of the total amount, and that includes pink, that have been bought. So 2, 3, 4, a fifth on the 13 is going to give me 18. So right now, I have a 2 out of 18 chance or probability that the next one, if this is the only data we have, assuming that's the only data we know, 2 out of 18 chance that the next one is going to be pink. Now, what we would also want to do is simplify that. So we want to see if there's anything in this fraction that can be reduced. So is there anything we can take out of 2 and 18? We could divide both by 2 or reduce, and that could go to 1 over 9. So there's a 1 in 9 chance basically that the next thing that's going to be bought is pink, and that's again theoretical probability or experimental probability because it's only based on that. We don't know if say with pink for example, we don't know if maybe breast cancer awareness month's coming up, something like that. That would really make that skyrocket. Or if there's a certain event or certain teams, if it, like we said, if it's a fundraiser, maybe one's going to skyrocket at certain times. The next one we had was number of total possible outcomes if we have compound events. So the example we have is if I were to spin a spinner and assume, my drawing's not perfect, but assume that it has an equal chance of landing on each of these 6 options here. And then these are my very well drawn marbles. I had a white one, a blue, a green, a red, and a black one. Let's say I'm doing one spin and grabbing at random 1 marble. What's the total possible outcome? What we need to think about is there's 6 possible outcomes in the first thing. There are 5 in the second. And those get multiplied together to give me 30 total possible outcomes that I could get. So that may seem like a lot for just 2 very simple things, just 1 out of 6 and 1 out of 5. The reason we end up with such a high number like this is because we have to think about every possible combination or permutation here. Sure, we could get A, but we could spin and land on A, grab the white one, A blue one, A red, A green, A black, and then we would have the same thing for each of these. So that's where those kind of 5 options, 5 options, 5 options, 5, 5, and 5, and that's where it builds up to that 30 mark that we're looking for. So hopefully this helps out. We'll try to make more in the future, maybe even lengthier with some higher up stuff. Let me know if that helped. Thanks.